Hi, my name's Dan, and today I'm going to be talking to you about Boolean Algebra, and we're going to do some simple examples. So in order to understand this, it would be helpful if you understand Boolean logic. You've come across and or, and not, and I'm going to be using the double ampersand symbol for and, I'm going to be using the double upright bar for or, and the exclamation mark for not. It would be also good if you knew of the Boolean Algebra rules. You don't need to have memorized them, but you need to have seen them. So the first example we're going to look at is quite a silly example. It's taking its inspiration from Hamlet, and Hamlet is famous for having said to be or not to be, and that is the question. So we're going to try and find out if we can get an answer for this. So we're going to take this statement, to be or not to be, and we're going to take to be as if it was a logical statement. I know it's not, but we're going to do it anyway. So let's isolate that, to be or not to be, and we're going to turn to be into a single word as if it was a variable. So to be or not to be, and then we're going to replace or not with the Boolean logic symbols. Here we go, to be or not to be. So we have one of our single variable rules is a or not a is equivalent to true. So in our statement to be or not to be is the equivalent of a, and we can apply this rule. So in that case, to be or not to be, the outcome is true. Okay, so that was quite silly. We're going to do a more straightforward but lengthier example now. I'm going to talk about my front door. So what we're going to do is to replace statements with single words so we can make it easier to do the algebra, effectively replacing these statements with variables. Here's the logic. I can get through my front door if the door is unlocked or the door is locked, but I have the key. In fact, the door is locked and I have the key. So let's start by replacing the statements with single words as if they were variables. So I can get through my front door if not locked or locked and got key. And let's isolate these and let's just move them around. We're going to replace the or and the and with Boolean algebra operators. And actually one of the things we should be doing here is binding together the second two terms, locked and got key, with brackets, because those two go together. So our final thing is not locked or locked ampersand got key. I know there's only three terms in this, but we can simplify this even further using Boolean algebra. So here we go. I'm going to go quite slowly so you can see all the different rules that are in play here. So the first rule we're going to use is the expanding the brackets rule. Here's the rule restated. A or B and C is equivalent to A or B in brackets and A or C. And in this situation, A is equivalent to not locked, B is equivalent to locked, and C is equivalent to got key. Now I know that this is maybe a little bit confusing because not locked and locked are actually related. However, when we're applying this rule, we take not locked as if it's independent from locked, and so we can apply the rule. So we're going to expand out the brackets, and here we have a nice little animation to show that happening. And then we bind these terms together with brackets so that we've got our final output. So this is not more simple than we started with, but bear with me because we're not actually finished yet. So we have a commutative rule. If you remember, this means that you can swap things around. So A or B is the same as B or A, and our left-hand term here, we're just going to swap those two around. Here we go. And how did that help us? Well, one of the single variable rules is A or not A is equivalent to true. And if we take A to be locked, then not A is not locked, and our left-hand side brackets, we've got an equivalent to A or not A. So we can replace locked or not locked with the value true. There we go. I'm just going to do a little bit of shuffling around. And in fact, let's swap the two things over. I'll rearrange again. Another single variable rule that we've got is A and true is equivalent to A. Now for this situation, we're going to take the whole of the left-hand side, which is not locked or got key, as being equivalent to the A in the rule. So not locked or got key and true is going to be an equivalent of A. So we can remove the and true, and we have our final statement here. Now this is more simple. Got not locked or got key. And actually, when we think about this, this does make sense, is that I can get through the door if either it is not locked or I have the key. So we reduced it down from 3 terms to 2 terms. It took a few steps, but I was doing it slowly, a little bit at a time. And that's the end from this video.